So, I want you to imagine signing a purchase order, right?
Yeah.
Just, authorizing $10 million worth of cutting-edge AI hardware.
Which is happening every single day right now, by the way.
Right. Every day. So you sign it, the servers arrive, they're these beautifully machined boxes, you plug them into your racks, and immediately, like almost instantly, the city grid just maxes out.
Yep. Just completely trips the breakers.
Exactly. And your data center floor actually starts buckling under the sheer physical weight of the cooling equipment.
Because people don't realize how heavy liquid cooling actually is.
Yeah, it's wild. And then just as you're trying to figure out the literal floor caving in, your legal team bursts into the room and shuts the entire operation down.
A total nightmare scenario.
Because as it turns out, you accidentally mixed highly regulated banking data with external insurance records on the exact same shared hard drive.
Which is a massive federal violation.
Right. So, welcome to the deep dive. Today, we are looking at this absolute frenzy, this rush, where organizations are frantically going out to buy the biggest, most expensive AI hardware they can find.
And completely skipping the fundamentals.
Yes. Completely ignoring the basic questions about what they actually intend to do with all that silicon.
I mean, it really is a modern gold rush, but instead of pickaxes, everyone is just buying massive computational engines.
Yeah.
And if your organization is currently, demanding massive GPU clusters, you really need to understand what that actually entails.
Because it's not just plug and play.
No, not at all. Because if leadership doesn't know exactly what workloads those chips are running, they aren't building an AI capability. They are building, well, an incredibly expensive liquid-cooled monument to bad planning.
I love that phrase. A monument to bad planning. Okay, let's unpack this because today we have our hands on something that is, frankly, incredibly rare and revealing.
You'll gold mine.
It really is. We aren't looking at some...
No PR spin on this one.
Right. We are looking at a highly detailed internal corporate framework. It's titled the AI Workload Requirements Questionnaire.
Such a dry title for such an explosive document.
It really is. And it's from this multi-subsidiary holding group called Digital Catalyst, designed for a workshop dated June 24, 2026.
Which is very recent.
Very. And this workshop brought together the parent organization, a major consultancy, and the hardware giant Supermicro.
And the stated purpose right at the top of this document, it is a masterclass in how to pump the brakes on the hype train.
Yeah, it really forces you to stop and think.
It's designed to rigorously map out the workloads, the data constraints, governance, and infrastructure phasing, all before a single piece of hardware is selected.
Before a single dollar is spent.
Exactly. That sequencing is literally the difference between a successful deployment and a career-ending IT disaster.
I mean, I was reading through these pages last night, and I realized this isn't just a dry IT checklist.
It's really not.
No, it's like this fascinating psychological and strategic mirror for any organization that's trying to adopt AI.
It exposes all the cracks.
It does. It asks questions that expose all the internal fault lines of a company. Like right in the business strategy section, it asks, and I quote, which business problems are painful enough to justify central AI investment?
I love that they use the word painful.
Right.
Wait.
Painful enough, it strips away all the vanity of wanting AI just so you can, put it in a shareholder report and sound innovative.
It demands a quantifiable reason.
Exactly. Like, why are we doing this?
Are you doing this to reduce operational costs? Are you trying to cut down on fraud? Are you generating new revenue? You have to pick a lane.
You can't just say, we want AI.
Exactly. Because if you don't define the business problem, you inevitably fall into the most catastrophic mistake companies make right now.
Which is prioritizing silicon over strategy.
Yes. The hardware first trap.
Let's talk about that trap, because the document explicitly calls it out in Section 2. The first massive risk they identify is buying the wrong GPU profile.
Which happens constantly.
Right. The blueprint warns that a company might go out and buy top-tier training hardware, but their early use cases are actually just basic internal search engines or simple chatbots.
And what's fascinating here is the sheer scale of the mismatch that can occur.
How bad of a mismatch are we talking?
Well, in traditional enterprise IT, if you buy a web server that's, a bit too powerful for your traffic, it's a minor waste of budget.
Right. You spend an extra $1,000, no big deal.
Exactly. The server still does the job perfectly well. But in the world of artificial intelligence, buying high-end training hardware for a basic conversational task is, it's functionally irrational.
It's just the wrong tool for the job.
Completely. It is the wrong architecture for the physics of the problem.
Reading this, it sounds to me like buying a fleet of massive ocean-going cargo ships before you even know if your business is transporting feather pillows or iron ore.
That's actually a perfect analogy.
Right. You just assume bigger is better, so you go out and buy the giant iron ore freighter.
And look, if you're shipping iron ore, you absolutely need that freighter. You need the structural reinforcement, the massive weight capacity, a deep draft.
You need the heavy machinery.
But if you are shipping feather pillows, you need sheer volume, but very little weight capacity.
Right. The pillows weigh nothing.
So that iron ore freighter is going to cost you an absolute fortune in fuel to move a fraction of the pillows that a specially designed lightweight barge could handle.
Which is just throwing money away.
Exactly. AI workloads have wildly different profiles for compute, for memory throughput, and for network bandwidth.
Well, wait, let me push back on this a little bit.
Yeah.
If I'm a CIO, right, and I have a massive budget,
Lucky you.
right, and I've been reading the news about how incredibly powerful these top-tier NVIDIA chips are.
Yeah.
Isn't a GPU just a GPU?
No.
But if I have the money, why would having a high-end chip be a bad thing? Doesn't more power just mean my internal chatbot runs incredibly fast?
It's a very logical assumption, but it fundamentally misunderstands what happens inside the silicon.
Okay, walk me through the silicon.
So a high-end GPU designed for training massive models, like teaching an AI an entirely new language from scratch, that chip is built for immense, sustained mathematical operations.
Like doing heavy math for months at a time.
Yes. Across a massive cluster of chips that are all working together, it prioritizes what we call interconnect speed.
Interconnect speed.
Yeah. That's the dedicated networking fabric that allows thousands of chips to talk to each other to solve one giant distributed math problem.
So the training chip is almost like a team of thousands of scientists solving one massive equation together for 6 months straight.
Exactly that. They have to constantly compare notes. But a chatbot doesn't need to learn a massive new data set.
It just needs to talk to people.
Right. It just needs to respond to thousands of individual users asking different questions at exactly the same time.
Well, it's not one big problem. It's thousands of tiny problems.
Yes. That is what we call an inference workload. It requires low latency and high concurrency.
So instead of scientists, it's more like, what?
It needs to act like 1,000 separate toll booth operators, quickly waving individual cars through one by one.
Oh, I see.
If you use the massive training chip for the toll booth job, you are wasting all that expensive, specialized interconnect hardware. The architecture just isn't optimized for thousands of tiny simultaneous inputs.
You're paying for scientists to work in a toll booth.
Exactly. You end up bottlenecking yourself. You're wasting massive amounts of power and cooling on silicon that is essentially just sitting idle, waiting for the next tiny user prompt.
Wow. Okay, and speaking of bottlenecks, the blueprint highlights another huge risk of this hardware-first trap. It warns against just guessing at the sizing.
Because guessing an AI infrastructure is incredibly dangerous.
Right. It points out that without knowing your user count, how many models you're actually running, and your data volume, sizing your data center becomes pure guesswork.
And you almost always guess wrong.
Yeah. If you guess too small, the applications crash under load, the users get frustrated, and they revolt.
But if you guess too big, you ruin your return on investment because you're paying for electricity and cooling you aren't even using.
But the blueprint takes it a step further. It warns about poor multi-tenancy design.
Which is the real killer for a holding company.
Yeah, because Digital Catalyst has multiple subsidiaries, right, like banks and insurers. And the document warns that sharing a platform could break regulatory rules.
If we connect this to the bigger picture, think about the legal architecture of a holding company.
Okay.
An insurance subsidiary and a retail banking subsidiary often have strict, federally mandated legal barriers between their data.
Right. They aren't allowed to see each other's files.
Exactly. But if the parent company just buys one massive cluster of GPUs and throws all the subsidiaries onto it to save money.
Oh, I see where this is going.
Yeah. They might inadvertently share the same memory space or the same storage backend.
Which means the data is physically mingling.
Yes. And if you don't rigorously plan the logical isolation of that hardware before you buy it, you are basically inviting a massive audit disaster.
Which perfectly explains, I think, the most profound line in this entire section of the document. Under the risks, it just says, missing the real bottleneck.
That line is so crucial.
It is. The blueprint states that the real constraint on AI adoption is rarely GPU availability.
It almost never is.
It says the real bottleneck is data access, data quality, governance, security, or operating ownership.
Because everyone in the industry obsesses over getting their hands on the latest hardware.
Right, it's a status symbol.
Exactly. Treating it like the ultimate supply chain victory. We secured the GPUs.
Hooray for us.
But you can have a room full of the most advanced silicon on Earth, and if your corporate data is locked away in 10 different legacy systems,
Oh, man.
if it's riddled with formatting errors and lacking clear access permissions, those GPUs are just going to sit there doing absolutely nothing.
It's burning electricity.
Yes. Your bottleneck is your own internal bureaucracy and data hygiene.
That is such a brutal reality check. I mean, you don't need a multi-million-dollar supercomputer if you don't even know which SharePoint folder your HR policies are saved in.
Exactly. Fix your SharePoint first.
Right. So we've established the trap. The workload has to dictate the hardware, not the other way around.
Absolutely.
But to do that, we have to define what an organization actually means when they say they are doing AI.
Because it means a dozen different things.
Right. As this document shows, it is an entire menagerie of different species of workloads. So let's look at how the blueprint deconstructs this.
Let's get into the categories.
The very first workload they list in Section 3 is Enterprise RAG, or Knowledge Search.
Retrieval Augmented Generation.
Yeah, that's the one.
This is honestly the absolute bread and butter of corporate AI right now.
It's everywhere.
Because it is how you safely connect an AI model to your approved enterprise data.
So instead of the AI just, hallucinating an answer based on whatever it read on the open internet 3 years ago.
Which is what ChatGPT does out of the box.
Right. Instead of that, our RAG acts like a very smart librarian who is only allowed to read the specific approved books that you place on their desk.
That's exactly how it works. You restrict the universe of its knowledge.
Okay.
But the magic of RAG isn't really the AI generating the text at the very end of the process.
It's not.
No. The heavy lifting is the search and retrieval process that happens before the AI even sees the prompt.
Oh, interesting. Break that down for me.
So when you ask a question, the system uses an embedding model to translate your text into a massive string of numbers.
A vector, right?
Yes, a vector. And that string of numbers represents the mathematical concept of your question.
Not the literal words, but the meaning behind them.
Exactly. It then plots that vector on a giant multidimensional graph inside what's called a vector database.
Okay, so it's not like a keyword search where it's looking for the exact letters I typed?
No, not at all. It's looking for concepts that are mathematically located near your question on this giant graph.
That is so cool.
It instantly finds the closest document chunks on that graph, retrieves them, and then passes those specific paragraphs to the language model to generate the final answer.
And then the model just summarizes what it was handed.
Precisely. Now, notice what isn't the star of the show in that process.
The heavy compute GPU.
Right.
Yeah, the document specifically notes that RG is far more dependent on data pipelines, on storage speeds, and vector database retrieval than it is on high-end training GPUs.
RG is a data management problem, not a massive compute problem.
That makes so much sense. But the blueprint brings up a massive governance issue here regarding RG.
It always comes back to governance.
Always. It asks this question: do search results need to respect existing document permissions?
And this raises an important question that a lot of pilot programs fail to consider entirely.
How so?
Well, in a complex organization, permission-aware retrieval is non-negotiable.
Give me an example.
Okay, if a junior analyst asks the RAG chatbot to summarize the upcoming quarterly earnings strategy.
Oh boy.
Right. The retrieval system must first verify that analyst's identity. If it just indexes everything on the corporate drive and lets the AI read it all without checking permissions.
The AI is just going to happily fetch the confidential board meeting minutes for the junior analyst?
Exactly. It's trying to be helpful.
It thinks it's doing a good job.
But you have just accidentally bypassed every internal security control in your company?
So the system actually has to filter that massive mathematical graph based on the user's security badge before it hands any documents to the AI librarian.
Yes, the vector search has to be tied to identity management.
That's incredibly complex. And the blueprint also insists that RG systems need citations and source links.
Which is critical for trust.
Right. It's not enough for the AI to just say, the travel policy allows business class flights.
Because it could be hallucinating that.
Exactly. It has to say, the policy allows it, and here's the link to page 4 of the employee handbook where it says that.
Verifiability is everything in enterprise AI.
Okay, so moving down the menagerie of workloads in the document, the next category is chatbots and virtual assistants.
Now, these often use RAG in the background, but when the blueprint lists chatbots as a separate workload, it is heavily focused on the interaction layer.
Mostly for customer-facing applications, right?
Exactly. And the platform requirements shift significantly here.
The document highlights um, conversation design, guardrails, human handoff protocols, and rigorous audit logging.
Yeah, and that changes the infrastructure needs completely.
How does that change the infrastructure from, say, a simple internal RRIG search?
Well, if you deploy a banking customer service bot, the infrastructure isn't just about finding a static answer.
Right.
It's about maintaining a secure, low-latency session state for that specific user.
It has to remember what you said 5 minutes ago in the chat
Exactly, and it requires capturing every single word exchanged for compliance laws.
because it's a bank.
Because it's a bank, and regulators will demand those logs. But crucially, it needs a system that can instantly analyze the sentiment and intent of the user.
So it's constantly judging my mood.
Yes. So if they say the word fraud, or if they get really angry, the system can seamlessly package the entire conversation context and transfer it to a human agent's dashboard in milliseconds.
Oh, wow.
That requires highly reliable inference capacity and strict workflow governance. It's a completely different beast than an internal search tool.
Okay, let's get into the heavy hitters. Because the blueprint draws a very hard line between two concepts that I see get conflated all the time.
I know exactly what you're going to say.
Fine-tuning versus model training or pre-training.
Yes.
I want to spend some time here because misunderstanding this distinction seems like a fantastic way to just burn a massive hole in the corporate budget.
It is the most expensive misunderstanding in the entire industry right now.
Okay, break it down for us. What is fine-tuning?
Fine-tuning is adapting an existing, already intelligent model to a highly specific domain, a specific task, or your corporate style.
So the model already knows how to think.
Exactly. You aren't teaching it the fundamentals of grammar or logic or how to speak English. You are taking a model that already knows how to speak and reason, and you are teaching it the specific jargon of your insurance claims department.
Or maybe tuning it so its output tone perfectly matches your brand's voice on Twitter or something.
Precisely. You are giving the AI a postgraduate degree in your specific business.
Okay, and the document says fine-tuning needs curated training data, a model registry, and experiment tracking.
Yes.
And it notes that it needs stronger GPUs than a simple chatbot requires, but significantly less infrastructure than full foundation model training.
Because the mathematical weights of the model are already largely set.
The heavy lifting is done.
Exactly. You are just running a relatively small data set through it to nudge those existing weights in a specific direction. It's computationally intensive, but it's not a supercomputer job.
But then we have model training or pre-training.
The big one.
Yeah. The blueprint defines this as creating models from massive datasets from scratch. And it flashes this massive warning sign in the text. It says, this is the most compute-intensive category.
This is where you are building the foundation from the absolute ground up.
Like OpenAI building GPT-4.
Exactly. You are feeding the system terabytes or even petabytes of raw, unstructured data to teach it the fundamental patterns of human language or reasoning or computer vision.
You're teaching it how to exist.
Yes. And the physical requirements for that are just staggering.
Right.
It requires distributed training across massive GPU clusters, incredibly high-speed networking so the chips stay perfectly synchronized, and blisteringly fast storage to constantly save the model's progress.
You know, the questionnaire actually asks the business leaders in Section 8, and I love this, it asks, does the organization genuinely need to train large models or only use and adapt existing models?
That's a very pointed question.
You could almost feel the consultant staring at the client over their glasses when they wrote that. Like, do you really need to do this?
Because the reality is 99% of enterprises do not need to pre-train large foundation models.
They just don't.
No. The document states explicitly that large-scale training is the most expensive AI workload, and it should only drive your hardware design if there is a massive business case and a crystal-clear data strategy.
Which most companies don't have.
Exactly. If a department head asks for a massive training cluster, this questionnaire forces them to prove that they actually possess the legally usable petabyte-scale data sets required to make it work.
And if they don't have the data,
Then buying the hardware to train on is completely pointless.
Yeah.
You're buying a factory with no raw materials to put on the assembly line.
okay, the blueprint also touches on a couple of other things. Analytics and machine learning, which covers traditional forecasting models.
The classic AI.
Right. and document intelligence, which is using AI to extract data from know your customer documents, invoices, and claims using OCR and layout analysis.
Very practical high ROI stuff.
But here's where it gets really interesting for me. The questionnaire introduces a category in Section 8.8 called agentic automation.
Oh man, this is the absolute cutting edge of enterprise deployment right now.
That sounds like sci-fi.
We are moving beyond AI that just talks to you to AI that actually acts on your behalf.
The document describes it as AI systems that can plan and take actions through tools, APIs, workflows, or enterprise applications.
Yes.
We aren't just talking about an AI that reads an invoice and summarizes it for a human. We are talking about an AI that reads the invoice, logs into the finance system, validates the vendor against a database, and actually initiates the payment itself.
That is the dividing line between a co-pilot and an agent.
A co-pilot versus an agent. Explain that.
A co-pilot drafts the email, but you review it and you physically click send.
You're in control.
Great. An agent drafts the email, checks the CRM for the client's history, sends the email, and updates the database entirely autonomously.
Without you doing anything.
Entirely autonomously. It accomplishes this through API integrations.
Oh.
The AI actually generates a structured command, like a JSON file, that tells your corporate software exactly what to do.
You know, as someone who tries to look at this from a business owner's perspective, my immediate thought is pure terror.
Oh, absolutely.
Right. If the AI is generating commands to execute actions in business systems, what happens when it hallucinates?
Because it will hallucinate eventually.
Exactly. What if an agentic AI gets confused by a weirdly formatted document and decides to automatically approve a highly sophisticated, fraudulent $50,000 insurance claim?
Which is exactly why the blueprint's focus here is entirely on governance.
It has to be.
The physical hardware required to run an agent isn't necessarily massive. It's often just inference hardware.
Right.
But the platform governance and the integration design are monumental.
The document asks two crucial things here. First, which systems can AI agents connect to?
Defining the blast radius.
Yes. And second, what actions must always require human approval?
That is the most important question in agent design.
It lists changing customer records, approving payments, opening claims, or making risk decisions as actions that might need a physical human button click.
You have to hard code those guardrails into the API layer before you ever deploy the agent.
You can't just tell the AI, be careful.
No, the AI will ignore you. You need an architecture where the AI has a verifiable identity on the network, where every single action it takes is immutably logged, and any action mathematically categorized as high risk automatically halts the autonomous workflow.
It just hits the brakes.
Yes. The system then routes a request to a dashboard where a human has to review the AI's logic and physically click approve.
So you build circuit breakers.
Exactly. If you don't design those circuit breakers on day one, you are basically deploying a rogue, hyperactive employee into your IT infrastructure operating at machine speed.
That is a terrifying image. Okay, so we've mapped out the software workloads.
We have?
We have RAG librarians checking permissions. We have fine-tuned models speaking our corporate jargon. And we have autonomous agents queuing up payments for human review.
A full suite of tools.
Now we have to look at the physical engines required to run all of this, because software eventually hits the laws of physics.
And in the realm of enterprise AI, that collision between abstract software design and thermodynamics is incredibly violent.
Violent is the right word. The blueprint forces the organization to confront the data center constraints of housing these engines.
You have to face the heat.
They lay out a hardware roster in Section 11, matching the workloads we just categorized to specific silicon families.
It's a great cheat sheet.
It really is. For smaller inference tasks, visual AI, and those enterprise array pipelines, they recommend the NVIDIA L4 or L40S class GPUs.
These are your reliable workhorses. If you are doing basic internal chatbots, extracting text from PDFs, or running smaller, fine-tuned models, these GPUs provide exactly the right balance of throughput, memory capacity, and power efficiency.
You don't need a supercomputer to read an invoice.
Exactly.
So to bring back our vehicle analogy from earlier, the L4 is the highly reliable delivery van.
I like that. Right.
It navigates the city streets, making thousands of small, efficient deliveries every hour.
Perfect for our...
But then, for large AI training, complex fine-tuning, and massive throughput inference, The blueprint points to the heavy artillery.
The big iron.
The NVIDIA H100, H200, B200, GB200, and GB300 class platforms.
So if the L4 is a delivery van, a GB300 cluster is a heavy-duty transcontinental freight train.
Just massive.
It is designed to move monolithic blocks of computational data at speeds and volumes that were physically impossible just a few years ago.
And it's worth noting they don't just mention NVIDIA. The blueprint explicitly lists AMD Instinct MI300X and MI325's class accelerators for training and inference, assuming the software ecosystem fits the client's needs.
Which is an important caveat.
Yeah, and they even mention Intel Gaudi class accelerators for selected use cases.
They are deliberately remaining vendor agnostic.
To avoid supply chain lock-in.
Because relying on a single vendor in a market where supply is severely constrained is a massive strategic vulnerability.
You have to keep your options open.
Absolutely. But regardless of whose heavy iron you purchase, the physical data center constraints remain identical.
The laws of physics don't care whose logo is on the chip.
No, they do not. And this is where the questionnaire gets very aggressive about matching the software to the physical environment.
It really grills them.
It starts grilling the client about model sizes and something called context lengths.
I want to break this down because it perfectly illustrates how a software choice dictates a physical reality.
It's the perfect example.
Why does the context length of an AI model matter to the data center manager who is just managing the physical building?
Okay, so think of a model's context length as its short-term working memory.
Like RAM and a regular computer.
Similar, yes. If you want an AI to read a one-page memo and summarize it, that requires a very small context window.
It's not holding much in its head.
Right. It takes up a minuscule amount of space in the GPU's onboard memory, which is known as VRAM.
Okay.
But if you want the AI to ingest a 500-page complex legal contract, hold all those clauses in its active memory simultaneously, and compare them to a second 500-page contract in real time to find discrepancies.
That's a massive amount of information to hold at once.
It requires an enormous context window.
And as I understand it, that memory requirement doesn't just scale linear, right? It scales quadratically.
Yes.
Because of how the AI has to pay attention to every single word and see how it relates to every other word in the document.
The math explodes exponentially.
And that massive working memory takes up literal physical space on the silicon chips.
Exactly. Large models with massive context windows devour GPU memory at an astonishing rate.
So what happens when you run out of space?
If the model and its working memory cannot physically fit onto the VRAM of a single GPU, you have to split the workload across multiple GPUs.
Okay.
Now, all those GPUs have to synchronize and talk to each other instantly to solve the problem.
Which brings us back to the interconnect speed.
Yes.
Which requires laying down incredibly expensive high-bandwidth networking cables. And while they are doing this intense communication, every single one of those chips is drawing maximum electrical power simultaneously.
Which brings us to the most visceral physical part of this questionnaire.
The power section.
It asks point blank in section 4, are there power, cooling, rack density, or data center constraints?
A very polite way of asking if you are about to blow up the building.
Right. And then, in bold text, it asks, is liquid cooling acceptable or required?
If we connect this to the bigger picture of corporate infrastructure, a traditional enterprise IT server rack, the kind that runs your email servers and your standard databases, that rack might draw somewhere between 5 to 10 kilowatts of power.
Just a normal humming server rack. Exactly. A modern AI server rack packed tightly with top-tier training GPUs can easily draw 40, 60, or even north of 100 kilowatts of power for a single rack.
100 kilowatts. The sheer amount of heat generated by 100 kilowatts of electricity in a footprint the size of a standard kitchen refrigerator.
Yeah.
That must be staggering.
It is quite literally physical fire hazard territory if it isn't managed perfectly.
Wow.
You cannot cool a 100 kilowatt rack just by blowing highly conditioned cold air on it with massive fans.
The air conditioning just can't keep up.
No, air simply cannot carry heat away fast enough at that density.
What happens if you try?
The silicon will reach its thermal limit in seconds, it will throttle its own performance to try and survive, and eventually it will just shut down or suffer physical damage.
It will literally cook itself.
Yes. That is why the blueprint explicitly forces the client to answer about direct-to-chip liquid cooling.
Direct-to-chip.
You actually have to pipe specially treated cooled liquid directly across microscopic cold plates that are mounted flush against the silicon chips.
So you have liquid physically running over the processors.
Essentially, yes.
Yeah.
to carry the thermal energy away.
So going back to our freight train analogy, if the business demands the GB300 cluster, you aren't just buying the train.
Not at all.
You actually have to rip up the concrete floors of your data center to reinforce them for the sheer weight of the fluid.
Because water is heavy.
Yeah. You have to install massive cooling distribution units, and you have to lay down an entirely new network of plumbing just to keep the train from melting itself into slag.
This is exactly why I tell organizations that their facilities will hit the wall of thermal and electrical capacity long before their CFO runs out of money to buy GPUs.
The physics stop you before the budget does.
Always. A department head might march into a meeting and declare, I have $10 million approved for an AI cluster.
Ta-da!
Right. But the data center manager will look at the spec sheet and say, I don't have the electrical capacity from the city grid to plug it in, and our facility isn't plumbed for the liquid cooling manifolds required to run it.
So you can't have it.
The laws of physics dictate the AI strategy. And this questionnaire forces everyone to acknowledge that before the purchase order is drafted.
Okay, so let's imagine a scenario where you successfully navigated the physical realities.
You did the impossible.
Right. You've purchased the right hardware for your workloads, you've reinforced the concrete floors, and you have freezing liquid pulsing safely over the silicon.
This system is humming.
Now comes what might actually be the hardest part of all. This brings us to the corporate politics, security, and compliance sections of the blueprint.
Oh, managing the humans.
Yes, managing the corporate roommates and building the data walls.
In a multi-subsidiary group like Digital Quadralist, this is the most dangerous minefield in the entire document.
More dangerous than a 100-kilowatt rack melting.
Yes, because we are moving from thermodynamics to human behavior and regulatory law.
Okay, fair point.
You can fix a pipe. You can't fix a massive GDPR fine.
We are looking at Section 6, 9, 10, and 12, dealing with tenancy and the commercial operating model. First up is the concept of multi-tenancy and the commercial model. The questionnaire asks in Section 6, is chargeback or showback required by subsidiary, department, or project?
Well, a shared enterprise AI platform is an incredibly expensive, scarce asset.
Very scarce.
If the parent company just pays for all the hardware centrally and lets any developer across the subsidiaries use it for free, human nature dictates exactly what will happen.
Rampant waste.
Yes, and you actually bill their departmental budget for it.
You take their money.
Right. Showback means you don't literally move the money, but you send their leadership a highly detailed report at the end of the month showing exactly how much their department's AI usage costs the parent company.
So it's more of a guilt trip than a bill.
Exactly. The blueprint forces the group to decide this early because implementing that kind of granular telemetry and billing quota management requires specific architectural decisions at the software layer.
You have to build the toll booths before you open the highway.
Exactly.
It also asks, do any subsidiaries require dedicated hardware or separate clusters?
Which is a huge structural question.
It forces them to decide if everyone is going to share a massive pool of GPUs to maximize utilization and save money, or if some tenants demand their own private islands of silicon.
And that leads directly into the concept of data walls.
Yes. Section 12. The questionnaire asks a seemingly simple yet explosive question. Can subsidiaries share models, prompts, datasets, embeddings, or fine-tuned models?
This is where the legal liability becomes very, very real.
Wait, let me stop you there.
Oh.
If I am the CEO of this holding company, right?
Okay.
And subsidiary A, let's say our retail banking arm, just spent 6 months and $1 million curating a brilliant, pristine data set to train an internal AI.
A great asset.
Why on earth wouldn't I share that data set with subsidiary B, the insurance arm? Isn't the entire point of building a group-wide, centralized AI platform to cross-pollinate our knowledge and save money?
This raises an incredibly important question about the tension between enterprise synergy and regulatory data sovereignty.
Synergy versus sovereignty.
Right. While sharing those assets sounds incredibly efficient on a spreadsheet, data residency laws and industry regulations often make it completely illegal.
Completely illegal.
Let's look closely at your scenario. Subsidiary A is a retail bank operating in Europe, which means they are subject to GDPR and incredibly strict banking secrecy laws.
Right.
Their data set is full of transaction histories, loan applications, and personally identifiable financial information. Yes, Subsidiary B is an insurance company operating globally. If you cross-pollinate that data, or even if you just allow the insurance AI model to train on the mathematical embeddings of the banking data, You have just breached regulatory data classifications.
Because the insurance side's AI model now implicitly knows things about the banking customers that the insurance company has absolutely no legal right to possess.
Exactly. Even if a human insurance agent isn't physically reading the banking records, the neural network has ingested those patterns into its mathematical weights.
It memorized them.
Yes. So if an insurance agent asks their AI a complex question about risk profiles, and the AI uses a pattern it's subtly learned from the banking data to formulate the answer,
Wow.
that is a data leakage incident. In AI security, we call this a model memorization or extraction risk.
Because clever prompters could potentially extract that banking data back out of the insurance model.
Precisely. That is why the blueprint explicitly asks what data classifications the platform will process.
It wants them to differentiate between public, internal, confidential, personal, financial, and regulated data.
You have to build absolute, impenetrable digital walls between the tenants who are sharing the same physical hardware.
Which is an incredibly complex engineering challenge.
It's massive.
It requires strict identity and access management, rigorous role-based access control, and often absolute logical isolation at the network and storage layers.
You cannot have a banking prompt accidentally saved into an insurance log file.
Not even once.
One time is a breach.
The regulatory reality facing these companies is stark. The blueprint asks in Section 9 if the AI will be used for high-risk decisions.
And it lists them out?
Yeah. Credit scoring, lending approvals, insurance pricing, claims processing, fraud detection, HR hiring, or customer risk decisions.
And this isn't just internal corporate paranoia or, best practice theory. The blueprint points to specific, enforceable external alignments.
It references the Bank of England and the Financial Conduct Authority's survey on AI and UK financial services.
Yes, Section 17.
And it maps directly to the European Banking Authority's requirements under the new EU AI Act.
These aren't just suggestions from a consultant. These are the laws of the land.
They have to comply.
If your AI is deciding who gets a mortgage or screening resumes to decide who gets hired, the regulatory bodies are going to demand to know exactly how that mathematical decision was made.
Which brings us to why the blueprint insists on the creation of a model registry.
The registry is your best friend.
The questionnaire asks if one is required, and for any regulated entity, the answer is unconditionally yes.
It has to be.
What exactly is a model registry?
A model registry is essentially a hypersecure vault and cryptographic audit trail for your AI assets.
Okay.
It logs exactly which version of a model was used on any given day, who approved it for production, what specific data sets it was trained on, and exactly what guardrails were in place.
So it's a paper trail.
It's an immutable paper trail.
Yeah.
When the auditors knock on your door because someone claimed your AI discriminated against them in a loan application.
The registry proves what happened.
Exactly. The model registry provides the lineage and governance evidence you need to defend the company. You simply cannot prove compliance without it.
So let's take a step back and look at the landscape we've just mapped out.
That's a lot.
It's huge. We have massive hardware constraints. We have staggering power and cooling requirements.
Water on the floor.
Water on the floor. We have intense corporate politics fighting over chargebacks and shared resources. And we have strict, legally mandated data walls that could trigger massive federal fines if breached.
Sounds impossible.
Right. As a leader, looking at all this overwhelming complexity, how do you actually launch an AI initiative without getting completely paralyzed by analysis?
How do you even start?
Yeah, how does a massive organization start doing this without blowing up the data center or breaking the law?
That is the genius of the final sections of the blueprint.
The phased roadmap.
Sections 13 and 14. The roadmap provides the antidote to that exact paralysis.
Breaks it down.
The overarching philosophy here is that the organization must learn to walk before it is allowed to run.
The blueprint breaks the rollout down into 3 distinct phases. And honestly, it provides a template that almost any company can borrow. Let's explore this roadmap. Phase 1 is simply called Day 1, Foundation and Fast Value.
The focus for Day 1 is deliberately severely restricted.
Very narrow.
The blueprint lists enterprise error, internal document search, basic internal chatbots, document intelligence pilots like standard OCR, and secure inference services.
Notice what is completely missing from that Day 1 list.
A lot of the fun stuff.
Yeah, there is no large-scale model training. There is no fine-tuning, There are absolutely no autonomous agents executing payments or changing records in the finance system.
Exactly. And the blueprint notes that the reason for this restricted day one focus is that these specific use cases can show business value quickly while safely validating the underlying plumbing of the platform.
It's a massive proving ground.
That's all it is.
You build the internal HR search bot first because it's low risk. If it hallucinates and fetches the wrong vacation policy document, an employee just gets temporarily annoyed.
A minor inconvenience.
But a customer doesn't lose money, and a European regulator doesn't issue a multi-million euro fine.
The blast radius is contained.
But behind the scenes, deploying that simple internal bot is actually doing heavy lifting.
It is forcing the organization to build the foundations.
It forces the IT and security teams to build the vector databases, verify that the document permissions actually filter correctly, set up the GPU inference scheduling, and prove that the single sign-on identity management actually works.
You are testing the integrity of the plumbing with clean, safe water before you ever attempt to pump hazardous, highly regulated chemicals through it.
That's a great way to put it.
You are building the operational muscle memory of the organization.
Okay, so once day one is stable, secure, and proven, the blueprint allows the organization to move to day two, controlled expansion.
Now we start opening the taps a little bit.
For day two, the blueprint targets production inference, departmental assistance, fine-tuning on specific corporate data, operationalizing the model registry, and officially activating those tenant quotas and chargeback systems we discussed earlier.
By day two, you have earned trust in the platform.
You've proven it works.
Because you have the model registry fully functional to track versions and approvals, you can safely allow departments to start fine-tuning models on their specific, siloed data.
You have the guardrails up.
Exactly. And because you have the chargeback system active and tested, you can open up the platform to more concurrent users without fear of runaway, unaccountable cloud costs.
Day two is about expanding capability only after the governance mechanisms are proven to hold under pressure.
Well, yes.
And finally, there is day three, Advanced AI Factory.
The Holy Grail.
This is what every executive wants on day one, which shouldn't be allowed to touch for years.
It's true.
Large foundation model training, distributed training across massive GPU fabrics, advanced agentic automation executing workflows, and multi-region failover capabilities.
The blueprint's criteria for entering day three is uncompromising.
It doesn't mess around.
It states explicitly, this should only be built when there is a proven business case, deep data readiness, and robust operational maturity.
Operational maturity is the absolute key phrase there.
It's the gatekeeper.
You do not hand the keys to the heavy-duty transcontinental freight train to someone who just got their learner's permit in the delivery van.
And you certainly don't let them drive the freight train if they haven't proven they know how to lay the tracks.
Exactly. So what does this all mean for you, the listener, trying to make sense of the AI hype cycle?
What's the takeaway?
Looking at the roadmap and the business questions laid out in this document, it means you cannot try to build day three on day one.
It will fail.
And I want to highlight something incredibly practical in the blueprint. It demands that the business defines quantifiable success metrics for 6, 12, and 24 months before a project is even approved.
Before they get a single GPU.
Right. It asks, what does success look like? And provides examples like a 15% reduction in manual data entry, faster customer response times, improved fraud detection accuracy, or reduced operational costs.
That requirement forces absolute accountability onto the business units.
They have to prove it's worth it.
If a subsidiary head demands a massive, dedicated GPU cluster for a day one chatbot, the Central Platform Committee can look at their proposal and say, your 6-month success metric is reducing call handle time by 10%.
We could do that cheaper.
We can achieve that metric with a much smaller, cheaper L4 GPU running a standard, well-architected RAGE pipeline. Your request for the massive cluster is denied.
It essentially weaponizes common sense against the hype.
It really does.
Right?
A successful enterprise AI platform is, at its very core, an exercise in restraint.
Restraint.
The underlying technology is staggering. I mean, it is capable of almost anything, from writing flawless code to identifying fraudulent financial transactions in milliseconds.
That's magic.
But the business itself must act as the filter. It must brutally prioritize high-value, lower-risk use cases first.
Walk before you run.
It has to build the internal muscle memory of governance, security, and operations before unleashing the full computational power of the data center.
As we wrap up this massive deep dive into the AI Workload Requirements questionnaire, I think about the journey we've just taken.
It's been quite a ride.
We started by exploring the catastrophic allure of buying hardware first. We learned that buying a massive cluster of GPUs without knowing exactly what workloads you are running is exactly like buying an iron or a freighter for a feather pillow delivery route.
A very expensive mistake.
We deconstructed the menagerie of workloads, recognizing that a RAG system checking document permissions is a fundamentally different software architecture and requires entirely different physical hardware than an autonomous agent executing workflows in a finance system.
We confronted the physical reality of silicon, context windows, and thermodynamics,
The melting racks.
acknowledging that data centers will hit the immovable wall of electrical capacity and liquid cooling requirements long before the IT budget runs dry.
We navigated the treacherous corporate politics of multi-tenancy, chargebacks, and the strict, legally mandated data walls required to keep banks and insurers on the right side of international law.
And we grounded all of that complexity in a pragmatic, phased roadmap
The day one, day two, day three model.
that demands companies walk, stumble, and learn the basics on day one before they are ever allowed to sprint on day three.
The next time your organization calls a strategy meeting and someone enthusiastically suggests that you all need to start doing AI or just blindly buying GPUs, you now have the exact blueprint of questions to ask.
You have the cheat sheet.
You can be the one in the room who asks about workload concurrency, data sovereignty, whether the application needs to execute actions or just search text, and whether the facility floor can physically support the weight of liquid cooling manifolds.
You'll be the smartest person in the room.
You have the tools to ensure your company's AI journey actually solves business problems rather than becoming a highly publicized multi-million-dollar disaster.
And as we close, I want to leave you with a final, lingering thought to mull over.
Okay, let's hear it.
We've spent this entire time talking about how to design and govern this infrastructure, but take a moment to think about what this infrastructure truly represents.
What do you mean?
Well, if an organization's AI architecture who is granted access to the GPUs, how fiercely data is walled off between departments, and whether the computing costs are aggressively hoarded or collaboratively shared.
Okay.
If that architecture is actually a direct physical manifestation of its internal data silos and corporate politics,
Oh, wow.
what secrets would your own company's AI architecture reveal about its true internal culture?
That is an incredibly powerful question to end on. If your AI reflects your culture, you better make sure your culture is ready. Thank you for joining us on this extensive exploration. Until next time, keep asking the hard questions before you sign the purchase order. Goodbye.